most important thing that we need to do on the moon is create as much living space as possible, as quickly as possible. Therefore, if you're producing a ton of oxygen and you've got 2.4 tons of iron, you can begin to make structures. And if you're producing 10 tons of oxygen, you have 24 tons of iron. 24 tons of iron can make a pretty darn good pressure vessel. And that pressure vessel, guess what? It has radiation protection because it's iron. So it's a multiplicative effect. It's the bootstrap. It's a classic bootstrap. I have on my desk at my office a 15 kilogram nickel iron asteroidal fragment it's called Cielo de Campo. It's from Argentina. That object has 87 grams per ton of gallium and 400 grams of germanium per ton. Germanium and gallium are very, very important in terms of high efficiency solar cells. So you're going to see very high value metals brought back, the platinum group metals, obviously. Then the secondary, the galliums, the germaniums, maybe cobalt. The bulk of the material by weight will be used out there, while the higher value materials will be brought back here to help support our civilization. That is a really important one that I think we're going to have to export from the Earth to there. You send a shipment of coal to the moon because it's tremendously important on the moon, because you can make mild steel. You can make a real nice Inconel steel with carbon, iron, and nickel. And Inconel is what the Space Shuttle main engine bell is made out of. Very high temperature, very high strength steel. So I think carbon, at least to the point way in the future to where you're getting carbon from the asteroids, or unless some of the deposits on the moon that the hydrogen may be tied up as CH4, maybe methane, I think carbon is going to be an Earth export rather than a in situ derived linear product, because if you look at the numbers, there's just not that much there. That's why God made nitrogen. Send ammonia, a shipment of ammonia to the moon. So you got nitrogen in liquid form, so you get a bunch of hydrogen at the same time. You take it up there and then you disassociate it. Well, guess what? You got a bunch of hydrogen now, and you got a bunch of nitrogen for your buffer gas, for your breathe gas. But if you're doing high production rates on the oxygen, you're going to get enough of the buffer gas to supply most of the human-related needs. But I think nitrogen, because nitrogen is important in the growth cycle of plants, I think we're going to be sending ammonia. There's going to be an Earth export to the moon as well. Equally important in relation to the resources exported back to the Earth is there was a book written as far back, it was written in 1965. And it was actually, I relied on it a lot for my research in Moonrush because it was a brilliant book when it came out. It was by a gentleman by the name of Neil Ruzick, called The Case for the Moon. Brilliant book, talking about manufacturing on the moon. He invented the cryostat. And the cryostat is used all over industry today. But the cryostat was invented because you could basically, in a perfect vacuum in the moon, you could dial in whatever temperature you wanted for industrial processes. Nanotechnology is a big thing everybody's talking about. It's the big wave of the future. But nanotechnology requires a vacuum. If you just had an atmosphere in there, that's too much friction for the micro machines to work. So in nanotechnology, what they do is the last part of the process, they put it in a vacuum, and then they have what's called a witness material, which is a platinum group metal, like palladium, and then they encapsulate it in as good of a vacuum as they can, but then the palladium attracts the residual molecules. And so the inside of this chip is in a vacuum. So I think something like nanotechnology manufacturing will be an export, a manufacturing export. Right now there's a global shortage of silicon for solar arrays. Now I don't think too much we'll bring just back bulk silicon, but bulk silicon is one of the byproducts of oxygen production. For every ton of oxygen that you're getting that's not coming from FeO3, which is an iron base, but it's coming from silicon, you get about a ton of silicon. One of the isotopes of silicon, called silicon-28, has 4 times the thermal dissipation of standard isotropic silicon. Silicon-28 is very difficult to purify on the Earth. It's actually The only place they get it is from Russia. And where they get it in Russia is from the same factories that are used to make nuclear weapons, because it's done from the same process that they use to separate the different isotopes of uranium for a nuclear bomb. But on the moon, it's much easier because you have the high vacuum, and depending again on your process for oxygen production, you'll have silicon vapor. And so it's much easier to use a gaseous diffusion method on the moon, and it's very good vacuum. In a high production environment, we could produce a tremendous amount of silicon-28 that could help continue the progress forward in silicon chips. We could export tons and tons and tons of that back to the Earth. The oxygen is the leak. The platinum group metals is the trickle. The silicon-28, the manufacturing and all, that's where the kind of the torrent begins. And so what I see is a very strong possibility that we could have a situation by the year 2100, if we want to do this, if we really care about the future, and the 9 billion people that'll be here by 2050, most mining of heavy metals will be done off Earth, where there's no environmental impact, there's no effluent clogging the streams, there's no farmland destroyed, and then the manufactured goods, the high-tech materials that are very difficult to make on Earth. After a certain point, it will become more cost-effective to build them on the moon, because transportation costs will fall, and we could just do it. And actually, all of these things don't weigh that much, but they have a lot of value. And so I think that's where the moon will go, and I think at that point is where the thought of a real lunar colony becomes to be more than just a fantasy of the future and a reality.